Today is about the extreme value theorem, which is another existence theorem. It guarantees the existence of extreme values. So the extreme value theorem says if f is continuous on a closed interval, then it must take on both a maximum and a minimum value on that interval. Your maximum and minimum values are y coordinates. They're the largest y coordinate in on that interval. So that's the extreme value theorem. So before we use the extreme value theorem, just a little bit of thinking. Why doesn't this function, 1 over x, have a maximum or a minimum value? And if you look at a graph of that function from -2 to 2, the reason it doesn't is because it doesn't satisfy the hypothesis of the mean value theorem. There is a discontinuity at x equals 0. X cubed is continuous, but it doesn't have a maximum or a minimum value. And again, we didn't satisfy the hypothesis of the mean value theorem. We don't have a closed interval. So in order to use the mean value theorem, you need a closed interval and you need a continuous function. So what about this function? F of x equals 3, which is a really boring function. It doesn't seem to have a maximum or a minimum value. It seems to always be 3. And so thinking of definition, from -1 to 2, closed interval, we are going to say that the maximum value is y equals 3, and that's also the minimum value. There is no place where the function is larger than 3. There is no place where the function is smaller than 3. So that means that 3 is both a maximum and a minimum for this function. Okay, a little bit of definitions. The local extreme values are the largest or smallest y coordinate in their neighborhood. So for this function, 0 is a local minimum because if I look at just this little region of the graph, 0 is the lowest value in that region. And -0.75 is also a local minimum because in that region, that is the smallest value around. For maximum, 0.8 is a local maximum because in that little region it's the highest value, and 1 is a local maximum because in this region 1 is the highest y coordinate around. Those are local extreme values. Absolute extreme values are going to be on the whole domain. What is the largest and smallest y coordinate on the whole domain? And so for this function, 1 is the absolute maximum because that is the tallest on the whole domain, and -0.75 is the absolute minimum. Another definition is critical points. Critical points are points at which the derivative is 0 or undefined. So take a minute, look at this graph and see where the critical points happen. I have a critical point at x equals 0. I have another critical point at x equals 8 because there's a corner. Looks like at x equals 0, that's a cusp. X equals 8 is a corner. And x equals 10 is a place where the derivative is 0. So that's a critical point. Maxes and mins can only happen at endpoints and critical points. So we have a minimum at this critical point, we have a maximum at this critical point, and another minimum here. Those are local. And then we also have endpoints, and so that at that endpoint we have a local maximum, and at this other one we also have a local maximum. And actually that endpoint and x equals 8, those are absolute maximums as well. For this function. So if you wanted to find maximum values, it would be very important to figure out where all your critical points are so that you can figure out what the value is at those critical points. Today's lesson will be about finding critical points. You will also, when you are finding maximum and minimum values, want to make sure that you're checking endpoints because you can have maximum and minimums occur at endpoints as well. So here's our first example. We're going to find the critical points for this function. So if you want to find critical points, step one is find f prime. So we're going to take the derivative of this equation, remembering to use the chain rule. Although on this particular function, the chain rule is kind of boring because the derivative of the baby, oops, I did that wrong. I didn't subtract 1 from my exponent. The derivative of the baby is 1. So this would be negative 1/3 times 1. The next thing I recommend you do is rewrite with positive exponents so that you can really see where your derivative is undefined, and if you have any like algebra to do in order to see the asymptotes, then you should do that algebra. So if I rewrite this a little bit, it would be 2 over 3 times the cube root of x minus 1. And when I see it written this way, I can see, well, if I want to set this equal to 0, which is one definition of critical point, so I'm going to definitely check for f prime is equal to 0. For this particular function, there is no x for which that is true because the numerator can never be 0. And then I also want to check where is f prime of x. Where does it not exist? So where do we have a discontinuity on our derivative? And that would be when we have the denominator equal to 0. So 3 times cube root of x minus 1 equals 0. And that's when f prime does not exist. I can divide both sides by 3. And so I have the cube root of x minus 1 equals 0. I can cube both sides. So I have x minus 1 is equal to 0. So I have x equals 1 as a critical point. And that's the only critical point, although actually that's called a critical value because that's only an x coordinate. A point should be an ordered pair. So we have 1, comma, if I plug 1 in to get my y coordinate, 1, comma 0 would be a critical point for this function. And that might be a maximum or a minimum. I don't know. We're not going to worry about that at the moment, but we know that that's where a maximum or a minimum could occur. Here's another function. We want to find the critical points. So we're going to take the derivative, remembering as we do so that we have to apply the chain rule and the product rule. Overall, though, this is a product, so I'm going to start with the product rule. So I'm going to take the derivative of x squared times e to the 3x left alone plus the derivative, x squared left alone times the derivative of e to the 3x times 3 because of the chain rule. So this part is chain, but overall, I have a product. Now I'm going to look, it looks to me like this function has no undefined spots because it's exponential, and it doesn't have a place where it's undefined, but it could equal 0. So I'm going to look at that. And I strongly recommend that you do factoring to find this. So we're going to go ahead and take an x out of both terms and an e to the 3x out of both terms. So we have 2 plus 3x. Now we set each of our factors equal to 0. This factor would equal 0 when x is equal to 0. This factor would never equal 0 because it's an exponential. And then this factor, 2 plus 3x equals 0. Well, 3x equals negative 2, and so x equals negative 2/3. So our critical values are x equals 0 and x equals negative 2/3. So we're going to go ahead and figure out what are our critical points. F of 0 would be 0, because 0 squared times anything would be 0. And f of negative 2/3 would be, well, it looks like 4/9 times e to the negative 2. So our critical points are 0, 0, and negative 2/3, comma 4, 9, 4 over 9 e squared. So those are our critical points. So here's our summary for today. The extreme value theorem is an existence theorem. It guarantees that you will have an absolute minimum or maximum. We begin to think about how we would find those maximums and minimums, but the extreme value theorem doesn't tell us how to do that. It just tells us that there will be one. Maxes and mins are y coordinates, so if you need to find a maximum value, you're looking for the value of the function, the y coordinate of the function. They occur at x coordinates, and the way we figure out where they occur is using those critical values. Relative maxes and mins are the extreme values just in their little neighborhood, and absolute are extreme values on the entire domain. Sometimes absolute are called global, so you can have a global extreme value. Those are absolute. Maxes and mins can only happen at critical points and endpoints, so if we want to find what the maxes and mins are, we'd better figure out where the critical points happen. And we do that by setting our derivative equal to 0 or undefined, because that's the definition of critical points. Eventually, as we're trying to figure out what these maximum values are, it's going to be very important that we also check endpoints for those values. All right, good luck. Thank you so much.